And now in this lecture we'll answer two questions. In the first question we find out the area of this green shape, and in the second question we find out the length of this line segment AP that equals to x, using two different methods. So we start with the first question. In the drawing we have a semicircle. We know that BC equals to 10 units in its length. That is to say, the diameter of this semicircle is equal to 10 units. In addition, we know that PC equals to 8 units in its length. This is angle ABC, this is right angle. Again, our task is to find out the area of this green shape. So first of all, we join points P and B together by a straight line. By joining points P and B, we create a peripheral angle BPC. Peripheral angle BPC subtends on BC, that is the diameter of the semicircle, and according to rule 5, any peripheral angle that subtends on the diameter of the semicircle or circle must be equal to 90 degrees in its size. So according to rule 5, any peripheral angle that subtends on the diameter of the circle must be equal to 90 degrees in its size. In the drawing we have a circle. AB is the diameter of this circle. Peripheral angle AEB subtends on AB, that is the diameter of the circle, and therefore peripheral angle AB equals to 90 degrees in its size according to this rule, rule 5. So I can actually implement rule 5 in our drawing. Why? Because in our drawing we have peripheral angle BPC that subtends on AB, that is the diameter of the semicircle, and therefore peripheral angle BPC must be equal to 90 degrees in its size according to rule 5. In the next step, we will implement the Pythagoras theorem on the right triangle BPC. So, according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. The hypotenuse of the right triangle BPC is BC, so the square of the hypotenuse is BC square, and BC square equals to BP square plus PC square. And again, according to the Pythagoras theorem, in this triangle BPC, the right triangle BPC, BC square, that is the square of the hypotenuse, equals to BP square plus PC square. The hypotenuse BC equals to 10 units in its length, therefore BC square is 10 squared, that is 100, and it is equal to BP square, PB square. PB is the missing side, so we leave it as it is. So it is PB square plus PC square. PC is 8, therefore PC square is 8 squared, that is 64. So in total, if you found out that 100 equals to PB square plus 64. So here we will subtract 64 from this equation, and we get that 100 minus 64 is 36 equals to PB square. Here we take a root out of this equation, and finally we get that PB, the missing side PB, is equal to the square root of 36, that is 6. So if we found out that the missing side PB This is the missing side PB that is equal to 6 units in its length. It is given us the question that AC is a straight line. So if you focus on the left side of the straight line AC at point P, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of the straight line AC at point P? We have this angle that is the right angle plus this missing angle. In total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. So in the right triangle APB, we define angle PAB, this angle is alpha. So this angle equals to alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. The big angle ABC is equal to 90 degrees in its size. This is the right angle. Angle ABP equals to 90 degrees minus alpha. Therefore, this missing angle PBC must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is equal to 90 degrees. That is the size of the big angle, angle ABC. Angle ABC is the right angle. So this missing angle must be equal to alpha. So in the right angle BPC, this angle equals to alpha. This angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we will prove that the right triangle ABP, this right triangle, is similar to the right triangle PBC. We prove that those two right triangles are similar to each other according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So if you prove that all the figures of the right triangle APB are correspondingly equal to all the figures of the right triangle BPC, and therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. We actually proved that the right triangle PBC is similar. This is the sign of similar to the right triangle APB according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side BC of the right triangle PBC over side AB of the right triangle APB is equal to side PB of the right triangle PBC. Actually, PB is the common side that belongs to both triangles, so it is equal to side PB of the right triangle PBC over side AP of the right triangle APB. And it is also equals to side PC of the right triangle PBC over side PB of the right triangle APB. So repeat again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side BC of the right triangle PBC over side AB of the right triangle APB is equals to side PB of the right triangle PBC over side AP of the right triangle APB, and it is also equals to side PC of the right triangle PBC over side PB of the right triangle APB. BC equals to 10 units in its length according to what is given us the question. Over AB. AB is the missing side, so we leave it as it is. And it is equals to PB. PB is 6 over AP. AP is the missing side, so we leave it as it is. And it is equals to PC. PC is 8. PC equals to 8 units in its length according to what is given us the question. Over PB. PB equals to 6. So in total, we have found out that ten over AB equals to 6 over AP equals to 8 over 6. So those two expressions are equal to each other. Therefore, we get the first equation from those two expressions. So according to the first equation, we get that 10 over AB equals to 8 over 6. 10 over AB equals to 8 over 6. Here, we first multiply this equation, and we get that 10 times 6 is 60 equals to 8AB. Here we divide this equation by 8, and finally we get that AB equals to 60 over 8. Here we divide this number both the numerator and the denominator of this number by 4, and we get that 60 over 4 is 15 and 8 over 4 is 2. So in total we found out that AB equals to 15 halves. AB equals to 15 halves units in its length. This is side AB, that equals to 15 halves. Those two expressions are also equal to each other. So we get the second equation from those two expressions. According to the second equation, we get that 6 over AB equals to 8 over 6. 6 over AP equals to 8 over 6. So here we first multiply this equation, and we get that 6 times 6 is 36. Is equal to 8 times AP. So here we will divide this equation by 8, and we get that AP equals to 36 over 8. So here we will divide both the numerator and the denominator of this number by 4, and we get that 36 over 4 is 9, and 8 over 4 is 2. So in total, we have found out that AP equals to 9/2 in its length. So actually, this is side AP is equals to 9/2 in its length. In the next step, we define the center of this semicircle. This point is point O. The diameter of this semicircle is 10, therefore the radius must be equal to 5. So the radius OB is 5. The radius OC is also 5. We join points P and O together by a straight line. PO is of course the radius of the semicircle, that is equals to 5 units in its length. In the next step, we define angle POB. This angle is theta. So I present you the law of cosines, and we implement the law of cosines. This triangle PBO. The law of cosines is true in any triangle. So actually this is triangle ABC, that could be any triangle. The length of side AB is A units, side AC equals to B units in its length, side BC equals to C units in its length. This is angle BAC, that equals to theta degrees in its size. According to the law of cosines, the following equation is true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So in the next step, we implement the law of cosines in this triangle POB. So according to the law of cosines, in triangle POB, cosine theta equals to 5 squared plus 5 squared minus 6 squared over 2 times 5 times 5. So repeat again, according to the law of cosines, in triangle POB, the following equation is true, that cosine theta equals to 5 squared plus 5 squared minus 6 squared over 2 times 5 times 5. So cosine theta equals to 5 squared. 5 squared is 25, plus 5 squared is 25. 25 plus 25 is 50. Minus 6 squared, it is 36. So it is minus 36 over 2 times 5 times 5 is 50. 50 minus 36 is 14 over 50. So in total, we have found out that cosine theta equals to 14 over 50. We would like to find out the value of theta itself. So how can we find out the value of theta? Actually, we have the rule that the inverse function cancels out the operation of the function. For example, we have the root is the opposite function of the square. So if we take number 3 and square it, we get 9, because 3 squared is 9. So the operation of the function on number 3, the result of the operation is 9. So now we have to operate the inverse function of a square that is a root on the result, and this will give us the origin number 3. That is to say, the inverse function cancels out the operation of the function. So the root of 9 is 3. So by operating the inverse function of the square that is a root on the result 9, we got the origin number 3 before the operation of the function on number 3. That gave us 9. So the inverse function cancels out the operation of the function. So we would like to find out the value of theta itself. Therefore, we have to operate the inverse function of cosine on the result that is 14/50. In this way, we get angle theta itself. The inverse function of cosine is arc cosine, and we'll operate the inverse function arc cosine on the result that is 14/50. In this way, we get angle theta itself. So arc cosine 14/50 equals to angle theta. Actually, arc cosine 14/50 you can calculate in the simple calculator. You get that theta itself equals to 73.74 degrees. You should find out that angle theta, that is the angle that I'm looking for, is equal to 73.74 degrees in its size. So here this is angle theta, that is equal to 73.74 degrees in its size. Our task is to find out the area of this green shape. In order to find out the area of this green shape, we have to find out the area of this segment VP. This is segment VP. So, what is the area of segment VP? What is the area of this segment VP? From the drawing, it is very easy to see that the area of this segment BP is equal to the area of sector BOP. Minus the area of triangle BOP. Repeat again, until we found out the area of this segment BP. The area of segment BP equals to the area of sector BOP minus the area of triangle BOP. So, what is a sector? A sector is a portion of a circle enclosed by two radii and the arc between them. The green shape AOB is sector. Sector AOB consists of two radii and arc AB between the two radii. Angle theta is the angle between the two radii, or angle theta is the angle between the legs of the sector. And the area of this sector equals to pi r squared, that is the area of the circle that contains the sector times angle theta, that is the angle between the legs of sector AOB, over 360 degrees. Repeat again, the area of the sector AOB equals to pi r square times the angle between the legs of sector AOB, that is theta, over 360 degrees. OB equals to OP equals to 5, it is the radius of the semicircle. Angle theta equals to 73.74 degrees in its size. So the area of this sector OBP equals to pi r square times the angle between the legs of the sector, that is 73.74 degrees, over 360 degrees. R is 5, therefore r square is 5 squared, that is 25. So pi r square is 25 pi times 73.74 degrees over 360 degrees. So in total, the value of this expression is equal to 16.088 square units. So we have found out the area of this sector BOP equals to 16.088 square units. Minus the area of triangle BOP. BO equals to 5. P also equals to 5, therefore triangle BOP is an associated triangle. PB, the base PB equals to 6 units in its length, according to what we already found out. So we have to find out the area of this associated triangle, triangle POB. In order to find out the area of this associated triangle, we draw from the vertex O perpendicular to the base PB. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and the base BP, this point M. We have the rule that the perpendicular to the base of an associated triangle bisect the base. PB is 6, therefore each half must be equal to 3. So PM equals to 3, and the other half is also 3. So when doing this construction, we get the right triangle OMP. Triangle OMP, 5 square equals to 3 square plus OM square. We subtract 3 square from this equation, and we get that 5 square minus 3 square equals to OM square. So OM square equals to 5 square, that is 25, minus 3 square, that is 9, 25 minus 9 is 16. So OM square equals to 16, we take root out of the equation, and we get that OM equals to the square root of 16, that is 4. So OM equals to 4 units in its length. We know that the area of any triangle equals to the base of the triangle times the height of the base over 2. We choose the base of SPB. The height is MO. Why the height is MO? Because of the fact that it creates 90 degrees with the base. Over 2. PB is 6, MO is 4, divided by 2. 4 over 2 is 2, and 2 times 6 is 12. So in total, we have found out the area of this associated triangle, triangle POB is equal to 12 square units. So the area of sector POB, that is 16.088 minus the area of the associated triangle, triangle POB, that is 12. So 16.088 minus 12 is 4.088. So if you found out that the area of segment BP is equal to 4.088 square units in its size. Okay, the area of segment BP equals to 4.088 square units in its size. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape equals to the area of the right triangle APB. Times the area of segment BP. Okay, again, let's find out the area of this green shape equals to the area of the big triangle APB minus the area of segment BP. What is the area of this right triangle APB? It is equals to the base AP times the height PB over 2. So it is equals to the base AP times the height, that is PB, over 2. AP is 4.5, PB is 6 divided by 2. 6 over 2 is 3, and 3 times 4.5 is 13.5. So in total we should find out that the area of this right triangle APB is equal to 13.5 square units in its size. Minus the area of segment BP. We already found out that the area of segment BP equals to 4.088 square units in its size. So 13.5 minus 4.088 is equal to 9.412 square units. So if you found out that the area of the green shape, that is the area that we are looking for in this question, is equal to 9.412 square units in its size. Okay, again, if you found out that the area of this green shape, that is the area that we're looking for in this question, is equal to 9.412 square units in its size. So we finish with the first question. In the next step, I present to you the second question, and we will solve the second question using two different methods. In this second question, our task is to find out the length of line segment AB that is equals to x. So we have to find out the value of x. In the drawing, we have a semicircle. We know that AB equals to 10 units in its length. According to what is given in the question, AB equals to 10 units, BC equals to 6 units in its length. And we also know that AP equals to PC equals to x. Our task is to find out the area of line segment AP that is equals to x. Or we have to find out the value of x. So first of all, we define the center of this semicircle. This point is point O. The diameter of this semicircle is AB that is equal to 10, therefore the radius must be equal to 5. So the radius OA is 5. The radius OB is also 5. And join points O and P together by straight line. OP is of course the radius of the semicircle that is equal to 5 units in its length. By doing all those constructions, we can create here the associated triangle AOP. Why triangle AOP is an associated triangle? Why triangle AOP is an associated triangle? Because side AO equals to side OP equals to 5. We have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides in triangle AOP, in the associated triangle AOP, we have those two angles that must be also equal to each other and their sizes. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other. Okay, so in the associated triangle AOP, alpha plus alpha is 2 alpha. Therefore, this third missing angle must be equal to 180 degrees minus 2 alpha. According to the rule that says that the sum of the angles in a triangle is equal to 180 degrees. Likewise, in the big associated triangle APC, those two sides are equal to each other. For that reason, it is an associated triangle. So in the big associated triangle APC, in front of those two equal sides, we have those two angles that must be equal to each other and their sizes. But the size of this angle PBC, is equal to alpha. Therefore, the size of this angle must be also equal to alpha because they are equal to each other, those two angles. So, in the big associated triangle APC, alpha plus alpha is 2 alpha. Therefore, this third missing angle must be equal to 180 degrees minus 2 alpha according to the same rule. So, in the next step, I'll copy the big associated triangle APC and the small associated triangle AOP in a new page, and we'll prove that those two associated triangles are similar to each other according to angle similarity rule. What is the length of side AC of the associated triangle APC? From the drawing, it is very easy to see that AC in total equals to 10 plus 6, that is 16. So the length of side AC of the associated triangle APC is equal to 16 units. So actually, those are the two associated triangles that are copied from the original drawing. This is the big associated triangle, triangle APC, and this is the small associated triangle, triangle APO. So, in the next step, we prove that those two associated triangles are similar to each other according to angle similarity rule. So write those two associated triangles are similar to each other. First of all, those two angles are both equal to 180 degrees minus 2 alpha, therefore they are equal to each other. In addition, those two angles are both equal to alpha, therefore they are equal to each other. And finally, those two angles are also equal to alpha, therefore they are both equal to alpha, therefore they are equal to each other. So we can prove that all the three angles of the big associated triangle, triangle APC, are correspondingly equal to all the angles of the small associated triangle, triangle APO. And therefore those two associated triangles are similar to each other according to angle similarity rule. So write it down. We can prove that the big associated triangle, triangle APC, this associated triangle, is similar, this is the sign of similar, to the small associated triangle, triangle APO, according to angle similarity rule. And from the fact that those two associated triangles are similar to each other, we will derive that the following relationship exists between their sides. We derive that side AC of the big associated triangle, triangle APC, over side AP of the small associated triangle, triangle APO, is equal to side PC of the big associated triangle, triangle APC, or side PO of the small associated triangle, triangle APO. So repeat again, from the fact that those two associated triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AC of the big associated triangle, triangle APC over side AP of the small associated triangle, triangle APO is equal to side PC of the big associated triangle, triangle APC over side PO of the small associated triangle, triangle APO. AC 16 over AP. AP is X, it is the line segment that we are looking for in this question. And it is equal to PC. PC is X, according to what is given as the question, over PO. PO equals to 5, it is the radius of the semicircle. So in total, we should find out that 16 over X equals to X over 5. So here we cross multiply this equation and we get that X squared equals to 16 times 5. So here we take a root out of this equation and finally we get that X equals to the square root of 16 times 5. The square root of 16 is 4, so inside the root we left only 5. 4 times square root of 5 is 8.94 units. So in total we should find out that the length of this line segment AP that is equal to X, it is equal to either 4 times square root of 5 units in its length, or in terms of numbers, AP that is equal to X is equal to 8.94 units in its length. Okay, so after we finish with the first method, in the next step I'll present to you how to find out the length of line segment AP that is equal to X according to the second method. In the second method, we use the rule that we have already used in the first question. According to the rule states that the perpendicular to the base of an associated triangle bisect the base. Okay. The big triangle APC is an isosceles triangle because AP equals to PC. From the vertex P, we go perpendicular on the base AC. AC is 10 plus 6, that is 16. So the length of the base AC is 16 units. Repeat again, from the vertex P, we go perpendicular on the base AC of the isosceles triangle APC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the tangent point of the perpendicular from point P and the base AC. This point is point M. So according to the rule that I mentioned, the perpendicular PM to the base AC bisects the base AC. The base AC in total is 16, therefore each half must be equal to 8. The first half is AM, that equals to 8 units. In the second half, MC is also 8. In the next step, we define the center of this semicircle. This point is point O. And we join points O and P together by a straight line. OP is of course the radius of the semicircle, that is equal to 5. What is the length of the small line segment? Line segment OA. OA equals to, this letter is M. What is the length of the small line segment? Line segment OM. OM equals to AM minus AO. Again, OM equals to AM minus AO. So I write it down. OM equals to AM minus AO. So OM in total equals to AM, that is 8, minus AO, that is 5. AO is the radius of the semicircle, that is 5. So it is, AO is 5. So in total, OM equals to 8 minus 5, that is 3. So OM equals to 3 units in its length. OM equals to 3 units in its length. So in the next step, I'll copy the right small triangle PMO in a new page and implement the Pythagoras theorem on this small right triangle PMO. Here by PT is the version for Pythagoras theorem. So actually, this is the small right triangle PMO that I copied from the original drawing according to the Pythagoras theorem. In this one right triangle PMO, PO squared, that is the square of the hypotenuse, equals to PM squared plus OM squared. So I write it down. PO squared, that is the square of the hypotenuse, is equal to PM square plus OM square. PO is 5, therefore PO squared is 5 squared, that is 25. And 25 equals to PM squared. PM is the missing side, so we need this it is. Plus OM squared. OM is 3, therefore OM squared is 3 squared, that is 9. So in total, if you found out that 25 equals to PM squared plus 9. Here we subtract 9 from this equation. And I get that 25 plus 9 is 16 equals to PM squared. Here we take a look out of this equation and finally we get that PM, the missing side PM, is equals to the square root of 16, that is 4. So actually we found out that the missing side PM equals to 4 units in its length. So in the next step I'll copy the right big triangle PMA in a new page and we'll implement the Pythagoras theorem on this right big triangle PMA. The hypotenuse PA equals to x units in itself. This is the line segment that we are looking for this question. AM equals to 8 and PM equals to 4. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right big triangle APM that according to the original domain. According to the Pythagoras theorem, in this big right triangle APM, PA squared, that is the square of the hypotenuse, equals to PM squared plus MA squared. So I write it down. PA squared, that is the square of the hypotenuse, is equal to PM squared plus AM squared. PA is x, therefore PA squared is x squared, and it is equal to PM squared. PM is 4, therefore PM squared is 4 squared, that is 16, plus AM squared. AM is 8, therefore AM squared is 8 squared, that is 64. So in total, we actually found out that x squared equals to 16 plus 64, that is 80. So x squared equals to 80. Here we substitute 80 by 16 times 5. So x squared equals to 16 times 5. So here we take a look out of this equation and we get that x equals to the square root of 16 times 5. The square root of 16 is 4. Inside the root we left only 5. 4 times square root of 5 is 8.94 units. So actually in both methods, found out that the length of this line segment AP that is equals to x, it is equal to either 4 times square root of 5 units in its length. From terms of numbers, the length of side AP that is equals to x is equal to 8.94 units in its length. So we finish with the second question. In the next step, I'll summarize the lecture. We'll start with the first question, of course. in the first question, our task is to find out the area of this green shape. So in the drawing, we have a semicircle. You know that BC equals to 10 units in this. That is to say, the diameter of this semicircle is equals to 10 units, because BC is the diameter. In addition, we know that this is angle ABC, that is the right angle. This is side PC, that is equals to 8 units in its length. Again, our task is to find out the area of this green shape. So in the first step, we join points P and B together by straight line. By joining points P and B, we create peripheral angle BPC. Peripheral angle BPC subtend on BC, that is the diameter of the semicircle. And according to rule 5, any peripheral angle that subtends on the diameter of the semicircle or circle must be equal to 90 degrees in its size. Therefore, peripheral angle BPC must be equal to 90 degrees in its size, according to rule 5. In the next step, we created the Pythagoras theorem on the right triangle BPC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle BPC, BC is the hypotenuse, so the square of the hypotenuse is BC square, and BC square must be equal to BP square plus BC square. So, repeat again, in the right triangle BPC, according to the Pythagoras theorem, BC square equals to BP square plus BC square. BC is 10, therefore BC square is 10 squared, that is 100, plus BP square. BP is the missing side of ellipticity, plus PC square. PC is 8, therefore PC square is 8 squared, that is 64. So in total, we should find out that 100 equals to PB square plus 64. Here we subtracted 64 from this equation, and finally found out that 100 minus 64 is 36, so PB square equals to 36. Here we took out of this equation, and finally found out that PB equals to the square root of 36, that is 6. So the length of this missing side PB is 6 units. In the next step, we define the center of this semicircle. This point is point O. The diameter BC is 10, therefore the radius must be equal to 5. The radius OB is 5, the radius OC is 5. We join points O and P together by straight line. OP is also the radius of this semicircle, therefore it is equal to 5 units in its length. By doing all those constructions, we can do the associated triangle BOP. Why triangle BOP is an associated triangle? Because side BO equals to side OP equals to 5. So in the associated triangle POB, in front of those two equal sides, we have those two angles that must be equal to each other. According to the rule that in front of equal sides in the triangle, there are equal angles. So those two angles must be equal to each other. So if we find the size of this angle is alpha, then the size of this, actually, we know that AC is a straight line. So if we focus on the left side of the straight line AC at point P, here the sum of the angles must be equal to 180 degrees according to rule 3. According to rule 3, rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of AC at point P? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in the right angle APB, we define angle BAP, this angle is alpha. This angle equals to 90 degrees, and therefore this missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in a triangle. It is given us the equation that the big angle ABC is the right angle. So, we know that angle ABP is 90 degrees minus alpha. Therefore, the missing angle PBO must be equal to 90 degrees minus 90 degrees minus alpha. This is alpha. So, this missing angle must be equal to alpha. y equals alpha plus 90 degrees minus alpha, it is equal to 90 degrees. That is the size of the big angle ABC. Okay, the big angle ABC is equal to 90 degrees in its size according to what is given as the question. So 90 degrees minus alpha plus alpha is 90 degrees. This is the size of the big angle ABC according to what is given in the question. So the missing angle PBC, this angle must be equal to alpha. So in the right triangle PBC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha. 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. So in the next step, we prove that the right triangle APB is similar to the right triangle BPC according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So we can prove that all the angles of the right triangle APB are correspondingly equal to all the angles of the right triangle PBC, and therefore those two right triangles are similar to each other according to angle similarity rule. So if we again, we should find out that triangle PBC similar to triangle APB according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side BC of the right triangle BPC over side AB of the right triangle APB is equal to side PB of the right triangle PBC over side AP of the right triangle APB, and it is also equal to side PC of the right triangle BPC over side PB of the right triangle APB. Okay, again, we derive that BC over AB equals to PB over AP equals to PC over PB. BC equals to 10 over AB. AB is the missing side, so we leave it as it is. And it is equals to PB, that is 6, over AP. AP is the missing side, so we leave it as it is. And it is also equals to PC, that is 8, over PB. PB is 6. So to that, we found out that 10 over AB equals to 6 over AP equals to 8 over 6, or 8/6. So actually, those two expressions are equal to each other, therefore we get the equation 1 from those two expressions. So according to equation 1, 10 over AB equals to 8 over 6. 10 over AB equals to 8 over 6. Here we cross multiply this equation and finally found out that 10 times 6 is 60, and 60 equals to 8 times AB. Here we divided this equation by 8 and finally found out that AB equals to 60 over 8. So here we divided both the numerator and the denominator of this number by 4 and finally found out that 60 over 4 is 15 and 8 over 4 is 2. So in total AB equals to 15 halves. This is side AB, that is equals to 15 halves. Likewise, those two expressions are also equal to each other. Therefore, okay, then the second equation from those two expressions. According to the second equation, 6 over AP equals to 8 over 6. Again, 6 over AP equals to 8 over 6. And again, according to the second equation, 6 over AP equals to 8 over 6. Here we cross multiply this equation and finally found out that 6 times 6 is 36 equals to 8 AP. Here we divided this equation by 8 and finally found out that AP equals to 36 over 8. Here we divided both the numerator and the denominator of this number by 4 and found out that 36 over 4 is 9 and 8 over 4 is 2. So in total we should find out that AEP, the missing side AEP, equals to 9 halves. This is the missing side AEP that is equals to 9 halves. In the next step, we define the center of this semicircle, this point O. The diameter BC is 10, therefore the radius is 5. So OB is the radius that is 5, OC is also the radius that is 5. We join points on P divided by side line. OP is also the radius that is 5. We define angle POB, this angle is theta. In the next step, I actually presented to you the law of cosines, implemented the law of cosines in this triangle POB. The law of cosines is true in any triangle. So actually, this is triangle ABC that could be any triangle. This triangle ABC, side AB equals to A unit in itself, side AC equals to B unit in itself, and side BC equals to C unit in itself. Angle BAC, this angle is theta, according to our definition. So, according to the law of cosines, in this triangle ABC that could be any triangle, the following equation is true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. We actually implemented the law of cosines in this triangle POB. According to the law of cosines, this triangle POB, cosine theta equals to 5 squared plus 5 squared minus 6. Cosine theta equals to 5 squared plus 5 squared minus 6 squared over 2 times 5 times 5. Okay, again, according to the law of cosines, in this triangle POB, cosine theta equals to 5 squared plus 5 squared minus 6 squared over 2 times 5 times 5. 5 squared is 25, so plus 5 squared is 25, 25 plus 25 is 50, minus 6 squared that is 36, so it is 50, minus 36 that is 14, 2 times 5 times 5 is 50, so in total cosine theta equals to 14 over 50. And again, cosine theta equals to 14 over 50. We would like to find out the value of theta itself. So in order to find out the value of theta itself, we have to operate the opposite function of cosine, that is r cosine on the result, that is 14 over 50. In this way, we get angle theta itself. Why? Because the inverse function of any function cancels out the operation of the function itself. So when we operated the function cosine on theta, the result is 14 over 50. In order to cancel out the operation of cosine, we have to operate the inverse function of cosine, that is r cosine, on the result. In this way, we get angle theta itself. It's exactly like the example that I presented to you. The root is the inverse function of a square. So we took number 3 and we squared it. The result is 9. So in order to cancel out the result of the function square, we have to operate the inverse function of a square, that is a root, on the result 9. So the root of 9 is 3. That is to say, the inverse function, the root cancels out the operation of the function of that is the square. The root functions cancel out the operation of the function square. In this way, we got the number 3, the only number 3, because the root of 9 is 3. So in order to cancel out the operation of the cosine, we have to operate the inverse function of cosine, that is arc cosine, on the result 14 over 50. In this way, we get angle theta itself. Arc cosine of 14 over 50 is 73.74 degrees. So in total, we can find out that angle theta equals to 73.74 degrees in its size. So actually, this is angle theta. The size of angle theta is 73.74 degrees. Okay. Our task is to find out the area of this green shape. In order to find out the area of this green shape, first of all, we have to find out the area of this segment BB. What is the area of segment BB? From the drawing, it is very easy to see that the area of segment BB equals to the area of sector POB minus the area of triangle POB. Mean again, the area of segment PB is equal to the area of sector POB minus the area of triangle POB. So, what is a sector? A sector is a portion of a circle with two radii and the arc between them. And again, shape AOB is a sector. It is a portion of a circle with two radii and the arc AB that is between the two radii. Angle theta is the angle between the two radii, or angle theta is the angle between the legs of the sector AOB. And the area of this sector AOB equals to pi r squared, that is the area of the circle that contains the sector, times theta over 360 degrees. So in order to find out the area of this sector POB, we will implement the new rule about the area of a sector. The area of this sector POB must be equal to the area of the circle that contains the sector, that is actually pi r squared, times the angle between the legs of the sector, that is 73.74 degrees, over 360 degrees. R is 5, therefore r squared is 5 squared, that is 25, so pi r squared is 25 pi, times the angle between the legs of the sector, that is 73.74 over 360 degrees. In total, the value of this expression is 16.088 square units. So if you found out that the area of this sector POB is equal to 16.088 square units in its size. And we have to find out also the area of this triangle POB. First of all, triangle POB is an associated triangle because PO equals to OB equals to 5. And the base of triangle POB is PB. PB equals to 6. So we have the rule that the perpendicular to the base of an associated triangle bisects the base. From point O, the vertex O becomes perpendicular on PB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to the construction. We define the touching point of the perpendicular from point O and PB. This point is point M. According to the rule that I mentioned, the perpendicular OM bisects both PB. PB is 6, therefore each half equals to 3. PM equals to 3, and MB also equals to 3. So the area of this associated triangle POB is equals to the base, that is PB, times the height, that is MO over 2. The base PB times the height MO over 2. PB is 6, OM, according to the Badalas theorem, OM is 4. Why OM is 4? Because in the right triangle PMO, 5 squared minus 3 squared, that is 16, equals to OM squared. OM squared is 16. We took out all the equation and found that OM equals to 4 units in its length. So OM is 4. So it is the base PB is 6, the height OM is 4 divided by 2. 4 over 2 is 2, and 2 times 6 is 12. So in total, we should find out that the area of the associated triangle POB is 12 square units. And 16.088, that is the area of sector POB, minus 12, that is the area of the associated triangle POB, is 4.088. So in total, if we found out the area of segment BB is equal to 4.088 square units in its size. there of the segment PB is equal to 4.08 square units in its size. Our task is to find out there of this green shape. There of the green shape is equal to there of the right triangle APB minus there of segment VP. Repeat again, there of the green shape in total equals to there of the right triangle APB minus there of segment PB. There of this right triangle APB is equal to the base that is 4 to the base that is AP times the height that is PB over 2. AP is 4.5, PB is 6 divided by 2. 6 over 2 is 3 and 3 times 4.5 is 13.5. So in total we should found out that the area of this right triangle APB is 13.5 minus the area of 7PB. We already found out that the area of 7PB equals to 4.088 square units. 13.5 plus 4.088 is 9.412 square units. So in total we should found out that the area of this green shape, that is the area that we're looking for in this question, it is equal to 9.412 square units in its size. So we finish with the first question. In the next step, I presented to you the second question, and we solve the second question using two different methods. We start with the first method. In the second question, our task is to find out the length of line segment AP that is equal to x. We have to find out the value of x. So in the drawing we have a semicircle. AB is 10, that is to say the diameter of this semicircle is 10 units. BC equals to 6 units in its length. AP equals to PC equals to x. And our test is to find out the value of AP that is equal to x. We have to find out the value of x. So first of all, we define the center of this semicircle. This point is point O. The diameter of the semicircle is 10, therefore the radius is 5. The radius OA is 5, the radius OB is 5. We join points O and P together by side line. OP is also the radius of this semicircle, that is 5. By doing all those constructions, we created the associated triangle, triangle AOP. Why triangle AOP is an associated triangle? Because side AO equals to side OP equals to 5. And we have the rule that in front of equal sides in the triangle there are equal angles. So if you focus on the associated triangle, triangle AOP, in front of those two equal sides, we have those two angles that are equal to each other, according to the rule that I mentioned. So if the size of this angle is alpha, then the size of this angle must be also equal to alpha because they are equal to each other. So in the right triangle, the associated triangle, the small associated triangle, triangle APO, alpha plus alpha is 2 alpha. Therefore, this third angle must be equal to 180 degrees minus 2 alpha, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Likewise, in the big associated triangle, triangle APO, APC, triangle APC is an associated triangle because side AP equals to side PC equals to x. So, in front of those two equal sides in the associated big triangle APC, we have those two angles that must be also equal to each other. So we know that the size of this angle is alpha, then the size of this angle must be also equal to alpha because they are equal to each other. So in the big associated triangle APC, alpha plus alpha is 2 alpha, therefore this previous angle must be equal to 180 degrees minus 2 alpha according to the same rule. So in the next step I copied the right triangle APC, I copied the big associated triangle APC and the small associated triangle AOP in a new page, and we prove that those two associated triangles are similar to each other according to angle similar to rule. So here, those are the two associated triangles that are coming from the original drawing. Why those two associated triangles are similar to each other? First of all, those two angles are both equal to 180 degrees minus 2 alpha, therefore they are equal to each other. In addition, those two angles are both equal to alpha, therefore they are equal to each other. And finally, those two angles are both equal to alpha, therefore they are equal to each other. So we can prove that all the figures on the big associated triangle APC are corresponding equal to all the figures of the small associated triangle APB, and therefore those two associated triangles are similar to each other according to angle similar to rule. And from the fact that those two associated triangles are similar to each other, we derive that the following relationship exists between their sides. First of all, we know that AC total equals to 10 plus 6, that is 16. So the length of AC is 16. So from the fact that those two isosceles triangles are similar to each other, we derive that the following relationship exists between their sides. We derive the side AC of the big isosceles triangle APC over side AP of the small isosceles triangle APO is equals to side PC of the big isosceles triangle APC over side PO of the small isosceles triangle APO. AC over AP equals to PC over PO. AC 16, PO is X. That is the line segment that we are looking for in this question. And we have PC is also X. PC is X over PO. PO is 5. So in total, we should find out that 16 over X equals to X over 5. Here we cross multiply this equation. We finally found out that X squared equals to 16 times 5. Here we took out of this equation and finally found out that X equals to the square root of 16 times 5. The square root of 16 is 4. So inside the root we left only with 5. So in total X equals to either 4 times square root of 5 or 4 times square root of 5 is 8.94 units. So we should find out that the length of this line segment AP is equals to X. It is equals to either 4 times square root of 5 units in its length. In terms of numbers, AP that is equals to X, it is equals to 8.94 units in its length. We finish with the first method. In the next step, I present it to you how to find out the length of side AP that is equals to X according to the second method. In the second method, we use the rule that we already used in the first question. According to the rule, the perpendicular to the base of an isosceles triangle bisect the base. Again, the perpendicular to the base of an isosceles triangle bisect the base. Triangle APC is an isosceles triangle because side AP equals to side PC equals to X. From the vertex P, we go perpendicular to the base AC. AC in totality is 16 because it is 10 plus 6, that is 16. So from the vertex P, we go perpendicular to the base AP. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the tangent point of the perpendicular from point P and AC. This point is point M. According to the rule that I mentioned, the perpendicular PM to the base AP bisect the perpendicular PM to the base AC bisect the base AC. AC is 16, therefore each half must be equal to 8. AM is 8 and MC is also 8. AM is 8, AO is 5, so the length of OM is AM minus AO. OM equals to AM minus AO. OM equals to AM, that is 8, minus AO, that is 5. So in total, OM equals to 8 minus 5, that is 3. The length of this small line segment OM is 3. In the next step, I copy the right triangle OPM. In a new page, we implemented the Pythagoras theorem on this right small triangle OPM. So this is the right small triangle OPM that I copied from the original drawing. According to the Pythagoras theorem, PO squared, that is the square of the hypotenuse, equals to PM squared plus OM squared. PO is 5, therefore PO squared is 5 squared, that is 25, and it is equals to PM squared. PM is the missing side, so we leave this it is plus OM squared. OM is 3, therefore OM squared is 3 squared, that is 9. So in total, we should find out that 25 equals to PM squared plus 9. Here we subtracted 9 from this equation and finally found out that PM squared equals to 25 minus 9 is 16. So PM squared equals to 16. We took out of this equation and finally found out that PM equals to the square root of 16, that is 4. So the missing side PM is 4. In the next step, I copied the right big triangle APM in a new page and we implemented the Pythagoras theorem on this right big triangle APM. This is the right big triangle APM that I copied from the original drawing. The hypotenuse AP is X, PM equals to 4, and AM equals to 8. According to the Pythagoras theorem, AP squared, that is the square of the hypotenuse, equals to PM squared plus AM squared. PA is X, therefore PA squared is X squared, and this equals to PM squared. PM is 4, therefore PM squared is 4 squared, that is 16. Plus AM squared. AM is 8, therefore AM squared is 8 squared, that is 64. So in total, we should find out that X squared equals to 16 plus 64. 16 plus 64 is 80. So X squared equals to 80. We substitute X squared we substitute x squared by 16 times 5. So x squared equals to 16 times 5. We took out of this equation and finally found out that x equals to the square root of 16 times 5. The square root of 16 is 4. Inside the root we left only with 5. So in both methods we found out actually that the error for line segment AP is equals to x. It is equals to either 4 times square root of 5 units in its length, or in terms of numbers, AP equals to 8.94 units in its length. Okay, thank you very much.